Today's video will be on macromolecules. So what are macromolecules? They are a very large molecule that is made up of many small molecules. So just some terminology here. We call a macromolecule a polymer and is made up of many repeated units of small molecules, and that molecule we call that a monomer. So depending on the monomer, you will get a polymer. So in nature, there are actually many examples of polymers. DNA, protein, starch, all these are long chains of molecules. But we have also created our own man-made synthetic polymers, all from petroleum fractions. So polyethylene, nylon, etc. are all synthetic polymers. So natural polymers, they occur naturally. So if you look at DNA is a polymer, and what are the monomers? It will be the 4 different nucleotides. So they are in repeating patterns. Then how about starch? Starch, the monomer is sugar. So each of these here is actually a sugar molecule. And then for protein, each of these here are amino acids. They are the monomer. How about synthetic polymers? You have many. Nylon, plastics, polyethylene, PVC, all these are synthetic polymers. So we will learn about how these synthetic polymers are formed. Look at all these plastics. Have you ever noticed the numbers at the bottom of certain plastic bottles? Each number actually represents a different type of polymer. So 1 represents PET, 2 is HDPE, it stands for high density polyethylene. Okay, and so on and so forth. All these different plastics have different monomers. See, the monomers are all different. So what is polymerization? It's when I join together the monomers to form a polymer. That process is called polymerization, and there are 2 types: addition polymerization and condensation polymerization. So what is addition polymerization? It occurs when the monomers join together without losing any molecules or atoms. Have you heard the word addition before? Yes, when we talk about reaction of alkenes, we call them addition reactions. So alkenes go through addition reactions. So not surprisingly, the monomers used in addition polymerization are also alkenes, or they have to be unsaturated, meaning they contain at least 1 carbon-carbon double bond. So when you have all these alkenes, if you place them together and you subject them to high pressure, high temperature, and you give a catalyst, they will all join together to form a large chain molecule, and we call that a polymer. So for example, if I have a monomer called ethene, the polymer will just be called poly bracket and the name of the monomer. That simple. So if you look at this example, I have all my ethene molecules together. When in polymerization, what happens is that the carbon-carbon double bond will break, and when it breaks, they will link up together. So this carbon atom over here will link up to this carbon atom of the neighboring ethene molecule, and they will all link up together and will form a large chain. So each of these here, these squares here, are all previously an individual monomer. So when the double bond breaks, in terms of electrons now, there will be another electron that is not paired up. So it will want to bond with another atom so that there will be a pair of electrons so that the carbon can have a full octet configuration. So what do you notice in this addition polymerization? Do you notice that your ethene monomers were all unsaturated because of the double bond? But when it became polyethylene, there's no more double bond. It's now a saturated molecule. And there's only 1 product form because it is simply the monomers joining together. So there's no loss in mass. What do I mean? The mass of all the monomers will be equal to the mass of polymer. Okay, there's no change in mass. You can look at this video for the mechanism of how addition polymerization works, but we do not need to know that. So how do I represent the polymerization of ethene in an equation? In the chemical equation, you can write it this way. N just refers to a large number because this large chain could be consisting of over 10,000 molecules all the way to 30,000 or more. And when they are subjected to high temperature and pressure in a catalyst, they will form a polymer. So in a polymer, is represented by this formula. Okay, all this one it shows you clearer. Your structural formula consists of your repeat unit, put a bracket and N. So I'll explain what I mean by repeat unit. Okay, your repeat unit will have this dangling bond which indicates the extension of the molecule by linking with different monomers. And you can see that in my polymer there is no more double bond. It is a single bond now as opposed to my monomer. This is my monomer. So when I want to find and write the formula of my polymer, I first need to know the repeat unit. So if I look at this chain over here, I can see that this is my repeat unit. Okay, so my repeat unit looks like that. So once I have my repeat unit, when I draw it out, if I were to represent the structural formula of my polymer, I'll just put a bracket and N. This is the structural formula of my polymer. This one over here is a portion of the polymer showing 3 repeat units. Okay, so there are slightly different representations of the polymer. So, for example, if I have the monomer propene, CH3CH2. Now, when I draw propene, sometimes you will draw it like that. Correct? You draw it as a straight chain. How is this representation 1 different from 2? They are actually the same molecule. They are both C3H6. But now I just represent my monomer in the H shape. It will make it easier to show which are the bonds that broken, because if I go to my addition polymerization, only this double bond will break. Okay, the other branch, if I consider this as a branch, there's no change happening to the CH3. So I can just write it like this, CH3. It's the same thing. Okay, so when I represent it in the H, the alphabet H shape, it's easier for me to see which are the carbon atoms that are linked. Okay, it would not involve this carbon atom that's circled in red. Okay, so I will represent it in the shape of a H shape, and then I put 3 of them together side by side, and I know that this is a carbon double bond that will break, and it will form a single bond, and you have your dangling bond over here, which shows that it's ready to attach it to a neighboring carbon atom. And then you put all of them together, you realize that this is your repeat unit over there, and you use that repeat unit and you draw the structural formula. How? You draw the repeat unit, put the bracket, and that is the structural formula of the polymer. And this is polypropene. And actually this polypropene is actually your plastic number 5. It's tried a rigid plastic and is used to make plastic containers. Then moving on. If now I want to deduce the monomer from the structural formula of the polymer, how do I do it? So over here I have an example of a portion of the polymer. First thing you need to do is you have to identify the repeat unit. So what is the repeat unit in this case? You realize it will be this one of the boxes there. Okay, that means it repeats itself. Okay, so you got the formula of the repeat unit. It will be like that with the dangling bonds. And then importantly, you have to convert the carbon-carbon single bond into a double bond. So this from a single bond, you have a double bond and no more dangling bonds. And that is your monomer. And the monomer actually has a name. It's called vinyl acetate, but I didn't ask you for the name. You just need to know the structure. So whenever you are drawing the monomer for me, definitely it must have a double bond. Okay, this slide we don't really need to know. It's just showing you when I have this branch OCOCH3, what does the actual structural formula looks like. So if you recall, what kind of linkage is this? C double bond O. Realize that this is actually a ester. This is an ester linkage. So there are many addition polymers. Polyethylene, also known as polyethylene, and there are actually two types of polyethylene. LDPE is low density and is your plastic number 4. HDPE is high density. So from the same monomer, you can have two types of polymers depending on the pressure that is subjected to, and these two polymers have different properties. Low density polyethylene is normally used for cling wrap. Okay, it's more flimsy, whereas your high density polyethylene is more rigid. Okay, the chains are packed closer together and is used for plastic bottle and buckets. And then PVC comes from this monomer over here. It has a chlorine atom over there, so it's called PVC, polyvinyl chloride, and this one is often made to use your water pipes. And your insulation for your wires is all using PVC. So it's plastic number 3. Then we have polystyrene, also known as styrofoam. This one is made from this monomer over here. You can watch the video about polystyrene. You are very familiar with styrofoam because you use it a lot when you tapao things or you tapao coffee or drinks. And there's many more. Okay, this perspex and polytetrafluoroethene, which is what is commonly used to coat non-stick pans, the black color substance. So why do addition polymers used so widely? Because they are also good insulators of heat. Okay, and they are strong. They can be very strong. They can hold things. They're quite rigid, and they're also resistant to chemical attack. So let's do checkpoint 1. The monomer has the following structural formula. Draw the structure of part of a polyvinyl alcohol molecule made from 2 monomer units. And B, write the repeat unit. Let's do B first. What's the repeat unit for this? So what did I mention? Your repeat unit from the carbon double bond, you just convert into a single bond. And then you make sure you have your dangling bonds. And the rest of the monomer remains unchanged. So this is your repeat unit. And then if I want to draw a structure of the polymer made from 2 monomer units, I will just draw the repeat unit twice. Okay, take note when you draw, for the OH, when you draw the OH, make sure that your bond is between carbon and oxygen. Okay, it should not be something like this, carbon OH. This is our mark wrong because the bond is not in the middle of OH, it's bonded to oxygen. This is the answer which I showed you just now already. Then, next question. The structure represents part of an addition polymer chain. Draw the structural formula of the monomer. So, how do I do this? First, identify your repeat unit. Can you find it? Yes. It's actually this one over here. And when I want to draw the monomer, I convert the carbon-carbon single bond into your double bond. So let's do that. The monomer will just be double bond and then the rest of the molecule remains intact, no change. Once again, take note, the line should be between carbon to carbon. Okay, so this is your monomer, done. Are you able to name this monomer? What is the name of this monomer? How many carbon atoms are there in one chain? You realize that there is actually 4. They are in one chain, just that it's drawn this way. And there's one double bond. So it's from the alkene family. What is this monomer? Yes, it's called butene. You can also draw and represent the monomer this way. CH3, CH2, double bond, CH, CH3. This is also butene. Okay, it's correct as well. So we are done with checkpoint 1. The next live lesson we will continue with condensation polymerization.